Hey, how you doing? My name's Elton. Welcome to the Container Show. It's a new year. It's a new lockdown here in the UK. So what better time to hunker down and learn loads of stuff about containers? So the theme for this month is observability. So new month, we've got 4 episodes all around that theme of observing what's going on inside your containers, which is really the stuff that you need for your day two operations when things go live. But you shouldn't really be going live without them. So you've got to get that stuff kind of in place before you go to production. This week we're all focusing on monitoring, which is the kind of the key part to see what's happening inside your containers. This is very different from a kind of traditional deployment using virtual machines or, heaven forbid, actual servers, where you have a small number of fairly static machines that you're collecting metrics from. In the container world, everything's very dynamic. You've got containers that are stopping and starting. When you do an upgrade, you're going to just bin a load of containers and start new ones. So you need a kind of dynamic way of collecting the metrics from all your components. And there's a really standard kind of established way of doing that now, which is using tools like Prometheus and Grafana, and that's what we're going to see today. So there's a whole bunch of demos. So after the talking head piece, after the introduction, we're going to switch over to demos. We're going to see what Prometheus looks like, what kind of metrics you collect, how you configure Prometheus to work with different platforms. So we'll see how you use it with Docker Swarm and with Kubernetes, so it can discover what it should be monitoring by itself. And then finally, we'll look at Grafana, which is the kind of dashboarding component. So Prometheus collects and stores all the metrics, and then Grafana gives you this nice visualization that shows you the kind of overall health of your application. So that's what we'll be doing today. If you're new to the show, hi. The format is we have a different theme every month. There's usually 3 or 4 episodes per month. There's a talking head bit at the beginning where I introduce everything, and then I'm going to switch to this camera here. I'm going to go and do demos for the whole rest of the show. To do that, I need to pull down my green screen and jiggle my microphone around. So while that happens, I'm going to switch to a short advert, which takes about 20 seconds, and then I will see you over there. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. These shows are live, unscripted, and unrehearsed, so if you like my style but you prefer something a little more polished, then you should check out my courses on Pluralsight. Pluralsight's an online training platform, and I've got tons of video courses on there that you're bound to find useful. And if you prefer to learn by reading, then you'll be interested in my books, Learn Docker in a Month of Lunches and Learn Kubernetes in a Month of Lunches, which are both published by Manning. And if you just want to see what I'm up to, then you can check out my blog. And now, back to the show. Okay, and here we go. So today's episode, we don't need anything special if you want to follow along. All the code samples, everything you need is up on GitHub. You just need Docker Desktop if you want to be following along with me today. This is episode ECS-V1. The V is for observability because I took the O for orchestration. So all the O episodes are about Docker and Kubernetes and Nomad. So V is going to be Prometheus and monitoring. Later on in the series, we're going to be looking at EFK, so Elasticsearch, Fluentd, and Kibana for logging. We're going to be looking at tracing routes through a distributed system. And then lastly, we'll look at kind of sidecars and how you plug all that stuff together. So lots of good stuff coming this month. I forgot to change my microphone. How's that? Hopefully that's better. Okay, so there's a few links up here. This is the GitHub page about the some basics around how you capture these metrics that you're going to put in your containers. So the book that I did, Docker in a Month of Lunches, I did a YouTube episode for every chapter. Chapter 8 covers this in more detail. If you're a Pluralsight subscriber, check out my course, Getting Started with Prometheus, which goes into a lot more detail about how you capture these metrics, the sort of metrics you want to capture, how you get up and running with Prometheus, more detail than I covered today. And if you're a .NET developer, my background's in .NET, but I do a lot more stuff now. Today's demos are going to be in everything but .NET. So I've got Go, Node.js, and Java, but you can do the same sorts of things with .NET. So if you're interested in that, click this link here, and that will take you to a sign-up page where I will send you a message when my new Udemy course comes out, which covers everything to do with .NET in running in Docker containers. Okay. If you want to follow along, all you need is Docker Desktop or some other way of running containers with Kubernetes, but you will be using Docker for the first part. Okay, and I've got Windows, so I'm running Docker Desktop on Windows. I'm in Linux container mode. I've got Kubernetes enabled, so I'm up and running and good to go. Okay, so first thing I need to do is add metrics to all my components. So the way this works in the container world is each of your containers has this endpoint, this HTTP endpoint, where it exposes a bunch of metrics in a really simple standard format. And what's inside those metrics really depends on the component. So if it's a web server, it'll be things like the number of HTTP requests it's served and the status of the responses and the duration of calculating the responses and all that sort of stuff. If it's a batch process that's listening on a message queue, it'll record how many messages have come in, how many have failed, all that sort of stuff. So the individual details will differ per component, but the approach for emitting those metrics in that HTTP endpoint is standard. And what Prometheus is going to do is you're going to run Prometheus in a container in that same platform. And it's going to go and pull those metrics in from all of those components and store them. So Prometheus does lots of things that we'll see today. So let's go and open up my terminal here and get up and running. So I'm already in the source code for today's episode. If I switch to demo 1, and I'm going to run up my application. It's the same astronomy picture of the day app that we've seen lots of times here. A few different components. One goes and fetches, one is a Java API that fetches the details of the image to show from the NASA API and caches that data. The next one is a Go website that connects to the Java API to find the image to show. And there's a Node.js API, which just kind of logs how much people use the site. So 3 different components, different languages. They've all been integrated with the Prometheus client library. So if you want to add Prometheus metrics to your application in a kind of meaningful way, then you need to do some code. You need to do some development work to bring in the standard client library into your application and use that to record the kind of metrics that you're interested in. So I've already done that for all of these components. If you're interested in seeing how that works, go to this link here, which will show you the source code, which is from my upcoming Kubernetes book, and that will show you the source code for all those demo apps. They're really simple. Prometheus integration is pretty standard. You can just bring the library into your app, and you get a whole bunch of stuff for free without even having to record your own metrics. If you want to record your own metrics, then you get another level of detail. Okay, fine. So let's go into this all up and running. So that looks good. So I'm going to browse to the app here. So the same mobile app that you've seen lots of times. Where's Firefox? Here it is. Today's picture is the small cloud of Magellan. Very nice. So that's just the up and running. So this is the Go component, but it's got the data of what image to show from the Java API. And every time that I refresh and hit the API, hit the website again, it will post a log to the Node.js API to say that it's been used. So those things are all kind of working away. Now they all have this metrics endpoint already enabled. So if I go and browse to localhost 8010 metrics, the Docker Compose file I've just used is all in the GitHub repo if you want to have a look at it. There's nothing interesting there. There's nothing specific to Prometheus at all. It's just a list of the container images to run. And this is the metrics endpoint for that Go web components. This is the website that actually renders the image. If you browse to the /metrics endpoint, ordinarily this would be a private endpoint. It gives me a whole bunch of stuff. This is the standard Prometheus format. So this example here, there's a couple of lines here which have prefixed with the pound sign or the hash sign. Those are comments, so just tell you a little bit about the metric that's about to follow. So this is called the Go info metric. The type of metric is a gauge. Prometheus has a small number of different types of metric you can record that you use for different things. I'm not going to go into that today, but my Pluralsight course covers all of that stuff. And here is the actual metric. So the name of the metric is Go info, and it just records some information about the application that's running. In this case, it's just telling me that it's Go 114.4. So you can include kind of textual information as well. But also in here, it tells me things like the number of Go routines that are running, which are kind of like threads in the Go world. So there's a whole bunch of stuff about the application runtime, so it knows this stuff is running in Go. And there's also some specific stuff that I can be capturing myself. There'll be HTTP requests, all that sort of stuff in there. The same thing I've got similarly for my log component, the access log, which is the Node.js component. It's a slightly different format because there's a little bit of white space to make it easier to read, but it's the same standard. So the help text and the type of the metric, and then the actual metric that comes through. So what we can see here is this process CPU user seconds total tells me how much CPU the process has been used since it started running. So that's a counter that's going to go up and up and up. So every time I browse to that, it tells me effectively how hard the component is working, how much CPU is using for the Node.js process inside that container, which is the only process in that container. But I've also got this custom metric here that tells me how many times the access log has been used. So how many times someone has come to the website, which then the website makes a request to this API. That just logs that total. That's a custom thing. So I wrote code for that, but all the other stuff is coming from the client library. So there's a client library for Prometheus for Go, which understands about all the things that you can collect about Go to make that a useful set of metrics. Same for Node.js, same for Java Spring Boot applications. They understand the runtime they're running in, and they give you metrics that are useful for that runtime. So even if you just include the client library and don't write any custom code, you're still going to get a ton of really useful stuff with kind of very little effort. And the last one is my Java API. So this has a slightly different URL. Instead of being /metrics, it's /actuator/Prometheus, which is just an artifact of how the framework, the Spring Boot framework, pulls this in. But it's the same thing. I've got a whole bunch of metrics in there, some of which come from the platform. So there's some stuff about the JVM, telling me how many classes have been loaded. It tells me how many CPUs it can see. So I can see that I've got 8 cores on my machine. It tells me how many counts of each type of event have been seen for different logs. And then because it's a Spring Boot app, so it's a REST API that runs in an HTTP server and it's using Tomcat. So I get information from Tomcat about the number of HTTP sessions, all that sort of stuff. So all those things very, very consistent, even though I'm using completely different frameworks for different purposes for my application components. These are all Linux containers, but the process is exactly the same for Windows containers. You can take a .NET client library, put it into your .NET Framework apps, and you'll get the same sort of stuff coming out. So that's the first step. So I'm going to skip over all that, how you do that, because I've done that for you. And we're more interested in what you can do with those metrics now. So each component exposes its own metrics endpoint, which just gives information about what it is doing, how hard it's working, what it's been doing in that time, and the other kind of lower level stuff that you get from the client library. And then you run Prometheus in a container. Prometheus is just a server component that does a few different things. You configure it to go and reach out to all those other containers to collect the metrics. Prometheus calls that scraping. So on a target, a time target, you'll say like every 10 seconds, go to those other containers and collect their metrics. And so it will fetch the metrics and then it stores them in its own database. And that database is a time series database. So every time it does a collection, it stores the current value that it's just received along with a timestamp so it knows when it got that value through. And then it also has an API, so you can query Prometheus and send it. Has its own query language. You can give it a query to say things like, how much CPU has the Java API used over the last 2 hours, and it will combine that. It'll work that out and give you the result back. It also has a really simple UI. So Prometheus does a whole bunch of stuff. It's a CNCF project. It's a graduated project. It's the second one to graduate after Kubernetes. It's wildly well used, so it's pretty safe thing to bet on. So if I have a look at the configuration here. I'm going to run Prometheus. Let me close down my terminal. I'm going to run Prometheus in a container alongside my application containers. And I'm not doing anything special here. I've got Prometheus, which is the team's own Prometheus image that's on Docker Hub. But I'm exposing port 1990, which is where the UI is. And I'm binding it to this configuration folder that I've got inside my source code. So Prometheus is driven by a config file that tells it where to go and find all the metrics that it should be scraping. Now, this particular Prometheus file is pretty simple. It's using static configuration, so a bunch of domain names. So when Prometheus starts up, it will see this configuration file, and it will know that it's supposed to scrape 3 different targets. Something called apod web, which is my Go web application, apod log, which is my Node.js access log component, and then the apod API, which is my Java image API. And most of those have a standard /metrics endpoint to go and collect the metrics from, but the Java API has a different path, and that's specified in the configuration too. This is static configuration. All that Prometheus will do is look up this domain name because it can be running in a container. Docker will pass it back the IP addresses of the other containers that it's trying to reach. So really simple, really static way of when you're running on a single machine, this is kind of the simplest way to get up and running. Okay, so I can go and deploy this now. So let's open my terminal again and clear this down. So I'm going to do my deployment with just that Prometheus component. I've split the Docker Compose files out just to make it easier to work with, so I'll get all these warnings about orphans, but that's fine. And now if I browse to the Prometheus UI here, so the Prometheus UI, kind of basic. It tells you things like alerts, the graph view, you can run queries to see what's being collected. The status pages tell you different things about the current status of Prometheus, so I can go and look at the configuration that's been loaded and confirm that it's the correct configuration that I expected it to load, which is really useful. Things like it just expands everything out. So I had a default scrape interval of 10 seconds set, but it's kind of filters that down to all of my jobs. The things like the default metrics path, it explicitly includes those. So all those things that I wanted are there, which is good. If I go and look at my targets and zoom out a little bit, it shows me that everything's up and running. So there is my apod API. There's one match for that domain name. So that's my single container, and it's up. And same for my log and my web component. So I've got one container for each of those. Prometheus has found them by the domain name. It's checked to see if it can reach them, and it has, and it's got the metrics from each of those components. So now if I go to the graph page again and have a look at this drop down, these are all the metrics that have been collected. So all the individual metrics pages that we've just looked at, Prometheus has gone and collected from all of those, and it's collecting every 10 seconds. So if I look, some of these are consistent across different components. So if I look at process CPU seconds total, then I'll see the results here for 2 different components. So I've got the same metric name for my my access log, my Node.js component, and the web component, which is my Go component. So the results are very broadly similar. They're both using like 900ths of a second of CPU so far, so they're pretty lightweight components. And they happen to use the same name. And I'm not going to go into the detail of how you do your naming, but it's really important to be able to aggregate across multiple different components, but also drill down into individual components. And the way Prometheus lets you do that is by having a single metric name with these different labels. So I've got this label that says instance, which tells me the particular component that's generated the metric. So I've got one instance for my log, my access log, one for my Go web application. They're both producing the same metric name, but I could, if I wanted to, aggregate across those and say, give me the total amount of CPU that's been used for all of my application components. If I have multiple containers running, I can aggregate across all the containers, or some of the containers for each component, or individual containers. So that's kind of how that stuff works. Not everything has a standard approach. So process CPU seconds total, most things should have that, but I think the Java component has a different name, so it has process CPU usage, but it shows me something similar for the APOD API. And then the other ones I was going to look at, if I scroll down here, those are kind of low-level operating system metrics. When you're collecting your metrics, the things you care about are at different levels, really. So you want that basic platform stuff, like how much CPU is being used, how much memory, how much network, if you get that information. How hard is the host running the platform? You know, the Java VM or the .NET runtime. And then you can get some other stuff as well, like the lower level things. So I can see the Go routines. Let me go and grab this as well. So for my Go component, if I drill down and look at Go routines, so we saw this in the raw view. If I look at that, that's for my web application. There's only one component that records a metric called that, and so far there are 8 Go routines being used. If I paste in my HTTP server requests and get rid of that bit at the end. So that's my server request count. This is coming from my Java API. So as part of the metrics it's collecting from the Tomcat server, it records how many requests have come in, how many HTTP requests, and the path and the outcome. So I can see that there are all GET requests. The outcomes, there were 2 successes. This was for the URI/image. There have been 6 requests for that. This is for the URI with the metrics endpoint. So this is Prometheus itself. Every time it calls in to the metrics endpoint, that logs the fact it's been recorded. And there's one 404 from some browser that I didn't pick up myself. So those are all the kind of things that we're interested in. It's all one metric called HTTP server requests, but I'm getting different labels telling me the outcome and the path. So again, I can aggregate across all of my requests to say, you know, how many requests have I got that were a 200 response, or I can drill down and say, you know, how many 503s was I getting for this particular component, or whatever I want to do. So I'm getting that kind of, I'm able to work at different levels from the same metric. And the last ones I'll look at are my kind of application specific ones. So if I go and look at access log total, so again, this is the one that we saw previously. Let me get rid of that because this is not, that's not going to work at all. So my access log total, this is coming from my Node.js component. It tells me how many things there have been, basically, how many calls to my application. And there's a similar piece of code inside my Java API, which is telling me how often a call has been made to fetch the API details. So this is telling me how often someone has come in to look at to get the lump of JSON with the details about the image to show. And right now it's telling me that there has been it also records this status label that tells me what the component actually did. So what did the API do when it got that request? There's one that says it was a success, and there are 5 that says they were cached. So every time someone comes in and calls into this API, it will either fetch the response from the NASA API and record this success count, or it will have its own cache response and it will send that back so it doesn't go to NASA. So this is telling me effectively that the cache is working correctly, because I should only go to NASA once and then I get my success response, and then every other time I should go to my own local cache, and that's what I'm getting from this counter. So it's not just the low level, how much CPU are you using. You can record kind of things that are interesting to tell you your application is working correctly as well. So maybe there's a configuration setting that says whether the cache should be used. If there's a big performance dip when we go live with some new deployment, then maybe that configuration has been turned off. And rather than having to dig through to see what was changed, we would see that in our dashboard, because we would have a dashboard that said the cache is empty. We're not using the cache at all every time we go to NASA, which is slowing everything down. Okay. So that's the kind of basics there. So I've got my application components in my containers. They all have a metrics endpoint that exposes the things that are relevant to that component. And then my Prometheus is configured to go and collect from all of those components, and it stores all the data and all that sort of stuff. And the other thing that we got here is because Prometheus uses this time series database, when I run these queries, I get the current value. But if I look at the graph view and scroll down to the last few minutes, then what I'll see is I get the change over time. So if I go and refresh this a few times, then we'll see some more data coming in, and I'll give a few seconds for this to scrape through. But if I were to scroll this down to 1 minute, so we can see these new things coming in here. So as well as storing the actual data, it has this timestamp, so you can do an aggregate query over different time periods and say, what's the trend that's happening over the last 5 minutes or the last hour or the last 24 hours, and that's what will drive your dashboards. So when you're looking at these dashboards, you want a high level picture of the overall health of your application, and we'll see when we come to the end of the session, you get that from these simple metrics can give you a whole kind of wealth of information that gives you the overall picture and lets you drill down into to see what's going on. Okay, cool. So that's what we've got there. So the downside with this approach that I've taken so far is this static list of endpoints that I need to go and query. Because when I'm running in a production environment, in a container platform that I'm running at scale, I'm not going to have a single container with a single domain name that I can go and look up and get the details from. I'm going to be running with dozens of containers that are distributed across dozens of nodes of my platform. And for that, I can't just have a list of DNS names, because in Docker Swarm and Docker Compose and Kubernetes, I have my DNS name for my component, but if I've got multiple containers underneath that, then the request will get load balanced. So if I try and configure Prometheus to use my DNS name, it'll go and scrape, and at one scrape, it'll get the response from container 1, and the next time it'll get a scrape from response from container 2, and the next time from container 3. So I'm not going to get what I want is it to scrape every container every time. So Prometheus has lots of different plugins for different platforms, so it can go and discover the targets that it should be collecting from. So you don't have to explicitly say, go to these DNS names. You set up a service discovery configuration that tells it to go and connect to the platform and get that information for itself. That's what we've got here. So I'm going to deploy it first so we can see it up and running, and then we'll go and look at how that service discovery works. So let's go back to my terminal here, close this down, and remove everything I've currently got running. So get rid of my Docker Compose that I'm running in a single server on my machine here, and then we're going to switch to Docker Swarm. So if you've seen the orchestration episodes, ECS-V1 and O2 and O3, then you've seen how Docker Compose and Docker Swarm and Kubernetes compare. Just really quickly showing you that the pattern for monitoring is pretty much the same for all of them. Some of the details change, but they change in the Prometheus configuration. So your application images stay the same because your containers expose their own metrics. Prometheus works in the same way. What you change is how you tell Prometheus to go and fetch all the information that it needs to have. So first of all, we're going to go to Docker Swarm. So I'm going to go to the right directory, and then I'm going to initialize my Swarm. So I'm just running Docker desktop. So I've got a single machine running Docker. I can switch to Swarm mode and be a single node Swarm. That's all fine. And then I'm going to create my configuration. So just like with Kubernetes has config map objects, Docker Swarm has these Docker config objects where you store your application configuration. So it lives outside of the image, so you can bring it into your container when you run your container. And then I'll deploy the stack itself. So this will run Prometheus in a container on my Docker Swarm cluster, which is a single machine at the moment. Okay, so that's all up and running. If I go and look at the configuration now, we can see how it's a lot more complicated when you're looking at service discovery. So this is the same goal that I have with my original Prometheus YAML file, where I had those 3 domain names listed. But now, like this, it's a ton more complicated because it's very flexible how you use your Prometheus configuration. You can really choose how you want to model your application. So if you have most of your applications that have a Prometheus metrics endpoint, then you can use like an opt-out model. So by default, everything that you run, Prometheus will find it and try and collect the metrics from it. Or if you've only got a few components that have Prometheus support, then you can use an opt-in model so that everything by default doesn't get collected, but they have to explicitly say they want to be collected. So what I've got here in this configuration, let me see, this is the opt-in approach. So what this setup is saying, that we're going to use the Docker Swarm service discovery. So this is telling Prometheus you're running in Docker Swarm. There's a component inside Prometheus that understands how to connect to the Docker Swarm API and query it to find out all the containers that are running. And we're just giving the information here of how it's going to connect to Docker Swarm. So this component will run on the manager node in the Swarm. It'll connect to the API. It'll say where are all your containers, and then it will evaluate the rules that are in the rest of this configuration file to see whether it should collect metrics from the containers that it finds. And we've got in here the terminology is a bit funky, and you'll want to dig into this a little bit more deeply, but this is very generic. So this Docker Swarm config file is exactly the same one you would use in your own Docker Swarm if you're running Prometheus. So there's nothing like complicated about this itself, because once you've understood it, you're just going to apply that across all of your clusters. what it's actually saying here is we're going to use labels to see whether there is to see whether the component is opting in to be scraped by Prometheus. So when you run your application definition inside your model, you can apply these labels. You'll have a label called Prometheus scrape. If it's got the value of true, then we're going to keep that target. So Prometheus, when it runs, it'll connect to the API. It'll get a list of all the containers that are running, and for each one, it will look at the labels that have been applied. And unless they have that label of Prometheus scrape with a value of true, then they'll get ignored. So only the ones that are opting in will actually get collected. And then we can also apply some other labels to say what path the metrics endpoint should be, and that gets fed into the address. And then down here, the port that it should use if it's not using a default port. And so the way that you do that stuff is that the service discovery returns some information in a label, and then you can configure that and modify that as part of this process. So the final label value is different from the one that got configured. So we're overriding the defaults for the path and the port. We're doing it with labels that we get from the container. We're setting them on labels that we set for Prometheus, and we have to use regular expressions for that. So it gets a bit funky, but you only do this once. So you can take this swarm config file and you can apply it to your own Prometheus, and it'll work in exactly the same way. So this is the generic part. Okay, the other things we're taking here is we're taking the service name, so the name of the component that's running, and we're applying that to the job label. So we've seen we have these labels saying to identify the component that generated the metrics. So that would give me the job label, which is a standard Prometheus label, and then the slot, which is the number of the container that's running. If I've got a service with 10 replicas, then I'll have the slot will be 1, 2, 3, 4 up to from 0 through to 9. And that's going into the instance label. So those are standard labels that we're giving it some meaning from the information that we get from service discovery. Okay, so that should all be up and running. So let's browse to my Prometheus that's running here now. So again, this is a new Prometheus that's running in a container on my swarm. Just checking that my configuration is loaded and all looks good. So that looks exactly what I was expecting. And now if I go to service discovery tab, which again is from the status here, I've got this swarm task configuration with 0 active targets. If I click on show more, it'll tell me all the things that it's found that are currently running in my swarm. So the things it will find are Prometheus itself. So it's found Prometheus and it's dropped it. So the target labels say that it's been dropped because it doesn't match the rules that I've got in my configuration. The configuration says you have to have a label applied in your container to say Prometheus scrape equals true. If you don't have that, you're not going to get included. And that's how this works. So it's already found the containers that are running in my swarm, but it's ignoring them all because none of them are opting in to my Prometheus collection, which is what I've set up in my configuration. So it's running, it's there, it's doing the scrapes, but there's nothing to scrape. So now if I go and deploy my application, this is the same APOD application, same container images, nothing different except that I'm modeling it now for Docker Swarm instead of Docker Compose. It's going to create my 3 components, it's going to plug them into their own networks. They're all going to communicate within this APOD network, but they're also connected to the Prometheus network where the Prometheus collector is running. So if I look at the YAML file here, what we've got is this is the bit that does the opt-in. Excuse me a second. So I've got my access log component here. That's the Node.js component. I'm publishing the port. I'm connecting to 2 networks, the application network, so we can find the other containers that represent my app, and also the monitoring network. So Prometheus is like a shared sub-service within my cluster here. So I'm running Prometheus in its own network. If you want to be able to opt in, then you've got to connect to that same network so that Prometheus can find your components. And then here's the opt-in bit. So I've got these labels that are being applied. Prometheus scrape equals true. And that's the thing that Prometheus is looking for. So as soon as I deploy this, Prometheus will see these new containers. When it looks at the labels for these containers, it will see the scrape equals true. So it will add them to its list of targets. I've also got the path where it's going to find the metrics and the port that it's going to use. And all those are just labels that are as part of my application model definition. And if this was completely standard, I could put defaults for this inside my Prometheus configuration and not have to specify it everywhere. And like I said, if I wanted to flip this and have an opt-out model, then I would change my Prometheus configuration to assume that everything is going to be scraped unless there are labels to specifically exclude certain components. So all these components have the same thing. They have the Prometheus scrape true. My Java component that has the strange path to get the metrics, that's specified in there. So everything that I need is in here, and everything that Prometheus needs is there to go and find those metrics. So now, if I go and browse back, we're going to look at the application itself. So this is the app. What am I doing here? This is the app running in Docker Swarm. Same picture, obviously, because it's the same image because it's the same day. If I go back to my Prometheus here, this is the service discovery. If I refresh that, we shall now see that there are 12 out of 14 active targets, and some of these are being brought through. So this is my what have I got here? I've got my scroll down to see where this is going. This is my access log component here. So these are all the things that the service discovery is able to find, all the metadata about this container. So it knows it's running on an Intel architecture. It knows which node it's running on within my swarm, all that sort of stuff. If I scroll up, we will see that it's got, where have we got here? You've got the IP address for the node itself. And then inside here, these are the things that have been relabeled. So this is the targets that are being picked up. It's got the job is the APOD log, and the instance is instance number 1, because it's the only one inside that cluster. If I switch now to targets, these are the things. Some of these are going to be up and down because they weren't ready when Prometheus made its call. But there's my instance 1 and instance 2 for my APOD API here. So there's my Java API with two. There are 2 containers running that service. They're both exposing metrics, and Prometheus has picked up from both of them. So that's all looking good. So now let's go and check out these metrics here. So image gallery request total. So again, it's the same set of metrics. It's the same containers that are running. If I refresh this a few times, just to make sure we're sending some data through. If I look at this metric here, it's my image gallery request. So this is from the Java API, just records how many requests have come through. So what I'm seeing here is that instance 1 has responded to all of these. There have been 10 so far. So the load balancing isn't very well distributed at the moment, because there should be 2 components. They should both be responding here. But what I'm seeing is at the moment, instance 1 has responded to everything. And if I go and look at the image load total, this is the bit that tells me whether it went to the NASA API or whether it loaded it from the cache. If I look at this again, here we are. Now we get some more useful information. This is coming from instance 1 and instance 2. So I can see instance 1 has had a success 1 time. So it went to the NASA API the very first time it was called. And for every subsequent one from instance 1 has come from the cache, which is exactly what I expect to see. Same for instance 2. The first one was a success, and every subsequent one came from the cache. So cache is working correctly. My image responses are coming from my different components, which is like what I expect to see, and everything's coming through and being picked up by Prometheus. So I'm not having to tell Prometheus, here are my endpoints, here are the URLs, here are the domain names you're going to go to, here are the paths. That's all part of the application model, which feeds into the metadata, which is where Prometheus is looking as part of its service discovery. So that's all looking really cool. If I now go and switch to graph mode for this one, so this is one we looked at previously when we saw the graph was pretty kind of boring because there wasn't very much data in there. What we see now is there are a few different lines. And each line is a combination of the labels. So for this one here, this is the number of cache responses from instance 1. This is the number of cache responses from instance 2. And then down at the bottom here, this is the number of success responses. They both have a value of 1. So this is the sort of information over time that we're going to feed into our dashboard. And this is where we get our fancy graphs that we can visualize in lots of different ways to basically tell us which, if we've got multiple containers that are serving responses, maybe some of them are overloaded. We need to dig into why the load balancing isn't working correctly. Maybe one of them isn't using its cache. We need to find out why one is misconfigured. All that sort of information. We'll get really, really high level information at a glance from our dashboard. Okay, so that's cool. So that's all working as expected. And if we switch to Kubernetes, is exactly the same principle. So we're still going to run our applications in containers. So each of my APOD components will run in its own pod. The pod will have that metrics endpoint that we can call into with Prometheus. We'll run Prometheus in another pod, and we'll connect Prometheus to the Kubernetes API. So we'll still use service discovery with a different configuration, but the goal will be the same, telling Prometheus to go and connect to the platform where it's running. It doesn't even have to be containerized. Obviously, I'm focusing on containers for the container show, but you can plug in Prometheus service discovery for your cloud platform too. So we can connect to the Azure APIs and go and fetch all your virtual machines and all that sort of stuff. So it can do a lot more than just connect to Docker and Kubernetes if that isn't enough for you. So with Kubernetes, it's a very similar approach. We're going to connect to the Kubernetes API, find out all the pods that are running, and then build the target list from that. And again, we can choose whether it's an opt-in or an opt-out model. I'm doing the opposite this time with Kubernetes just to show you the difference, but that's entirely depends on whether the majority of your components have Prometheus support or not, and that's how you'll choose to model your service discovery. Okay, so back to the terminal here. We're going to remove everything that I've got so far. So if I leave Docker Swarm, and I've only got one node, so the -f flag says forcibly leave the swarm, so it can get rid of everything. It'll stop all my containers. It'll get rid of all the Docker networks, all that sort of stuff. It'll switch my Docker node back to a single Docker machine. If I look at to see what's running, I should have nothing. So I've got no containers running, so I'm kind of back to normal. If I look at the nodes, make sure I'm connected to my Docker desktop. So there's my Docker desktop node. So I'm running in Kubernetes as well. So Docker desktop gives me that really easily. And when I make my deployments, I'll be using a namespace for my Prometheus deployment. So far, I don't have that deployed, so I've just got my standard system namespaces and the default namespace. When I deploy Prometheus, it's going to go into its own monitoring namespace. So again, I'm treating the monitoring components as a subsystem, a shared subsystem that all my application components can feed into. Maybe I'm using a different namespace for each project or a different namespace for each environment, but they're all going to connect and be picked up by my Prometheus namespace. Okay, so let's go and have a look at the alternative setup that we're going to be using for Kubernetes. So again, it's kind of ugly and a bit difficult to read, but again, it's completely generic. So if you want to use Prometheus in your Kubernetes cluster, this is what you can use as a starting point. The only things that you'll configure are the differences in the configuration will be where you run your components and what rules you want to bake in, and that'll be your choice. And you'll have to build your own configuration around that. What this is saying is same as before. This is going to be this is a config map, by the way. So this is YAML within YAML. So when I deploy this to my Kubernetes cluster, I'll have this config map with a whole bunch of YAML in there that gets surfaced as this prometheus.yaml file, which is what the pod will be looking for. I've got my scrape interval defined as 10 seconds, and then I'm using Kubernetes SD configuration. So Kubernetes service discovery rather than Docker Swarm, but it takes the same approach. It connects to the Kubernetes API, gets a whole load of metadata, and then you can use that metadata to filter out targets. So what I'm doing inside here, if I scroll down, instead of using labels, container labels that I'm using in Docker, I'm using pod annotations to do the same thing, but this is an opt-out model. So by default, every pod that it finds in the where are we here? In the default namespace. So it will look to see if you're in the default namespace. So the action will be keep. So the metadata that comes from Kubernetes, if the namespace for the pod is default, then we're going to keep those targets, except if they have a Prometheus IO scrape annotation with the value of false. So this is opt out. As soon as I find you, if you're in the default namespace, I'm going to start scraping from you, unless you have an annotation that says scrape equals false, and then you're going to get dropped. So it's going to drop anything that doesn't explicitly want to be collected. So again, for my APOD app, every component does expose metrics, so I can run them in my default namespace. Everything will get picked up. But if I was running a combination of different components, some didn't have metrics, I'd have to add annotations to the pod template for those components to say we're going to ignore those, so don't scrape those when they come through. Okay, and the rest of this stuff is achieving the same goal with that same kind of complicated logic to define where the configuration is set up. If there's an annotation present of path, then get that value and use it to replace the metrics path. So again, if you have a custom path, which my Java component does, I can express that inside my pod template with an annotation, and the same thing with the port here. And then the last two things for that job and that instance label, I'm using the pod name for the instance label, and the application label, the Kubernetes label, goes into the application as the instance label as the job label for Prometheus. So again, I'm using those. The final end result will be all of my pods with some labels to distinguish where the metrics came from, and the earlier steps of this configuration are being used to configure whether Prometheus should include those targets in its scraping manifest, and when it does, what path to use and what port to use. So looks complicated, is completely generic. If you weren't, the only thing that would change is if you wanted to take the same approach, but you were using a custom namespace, then you would change the Kubernetes namespaces where you were looking for your pods. Okay, fine. So let's go and close this down, and let's get everything up and running. So clear some space. And I'm going to go to my demo3 folder. Inside the demo3 folder, again, it's all in GitHub. You can see all the stuff. I'm not going to go through it in detail because I've covered most of that in other episodes. I've got all the YAML files for my deployments and my services for Prometheus itself, for the APOD app, and for Grafana, which we'll come to shortly. So I'm going to deploy Prometheus first of all. I'm going to create a whole bunch of stuff. Prometheus needs to connect to the Kubernetes API, just like with my Docker Swarm service discovery, it has to connect to the Docker Swarm API. It's going to ask Prometheus, it's going to ask Kubernetes about all of the pods and getting all the information about the metadata and all that stuff. It needs to be allowed access to do that. So that's what these other things are. So I'm creating this cluster role and this cluster role binding to say that my Prometheus, the account where the Prometheus service runs, it's going to connect. It's going to be allowed to connect to the Kubernetes API. It's going to be allowed to query certain types of object. That's all that's doing in there. That part of the API is changing shortly. So that's why I'm getting this warning saying that the definition I'm using right now is going to be good for another year or so. But when I come to Kubernetes 122, it's going to be deprecated, and I need to change the modeling of that RBAC component. Okay, so now that's up and running. So I've got a completely different Prometheus now. It's going to be the same. It's going to look exactly the same. Let's clear down everything that's there because I've got all these things that are open from previous containers and stuff. So this is Prometheus 1991 is where I'm running it on my Kubernetes cluster. I've got no active targets right now because although it's looking for all my pods, and there are a whole bunch of pods there are 14 that are already there, they're all system pods. So they're not in the default namespaces. You know, the Kubernetes API server runs in a pod and the DNS runs in a pod, and all those internal components. So if I look down here, what we'll see is it's found itself. So it's found Prometheus. That's in the monitoring namespace, so that won't be included. It's only looking for things that are in the default namespace. And the same if you go down, if you run this yourself, you'll see I've got my kube system stuff here. So there's core DNS running in the kube system namespace. So it finds everything. It records the fact in this screen that it's found these services, but it's not including them because they're not matching the rules that we set up in configuration. Okay, so now if I deploy my APod application, so let's clear this down. And again, it's the same application running model for Kubernetes rather than Docker Swarm or Docker Compose. So I've got services for each component. I've got deployment. I think the Java API is running with a couple of pods. Let's just double check that. So if I look at the pods in the default namespace, I've got my my Java API. There are two of those. My access log, the Node.js thing, and the Go web application. They're all there. They're all running. They're all pretty lightweight, so they start pretty quickly. So now if I browse to this new deployment of the application, which is on my local host 8014, same picture, obviously, but now it's all being routed through Kubernetes, which is going to my multiple image APIs. It's using my access log API. They still have those metrics endpoints and all that sort of stuff, so that's still all available. But of course, in a production deployment, I could hide that and make that unavailable to the outside world by using ingress rules and all that sort of stuff. But for this kind of simple deployment, I've got everything up and running there. If I go back to my service discovery tab here and refresh, then now there are 18 target now and 4 of them are being included. So if I scroll down to the ones, zoom out so we can see the ones that are being included. Wow, got to zoom out lots. So I've got my my default namespace here. What have we got here? I've got my yeah, this looks good. So default namespace. I've got my replica. It knows there's a replica set. Managing the pod. Here's my APod web, and it knows the pod IP address. So it's bypassing the service, the Kubernetes service, which has load balancing in there. I'm only looking at the pods, so it's found the individual pods and it will connect them by the IP address. This is why you need to have that API integration and the dynamic service discovery. Because if this pod gets replaced as part of an upgrade, then the new pod will have a new IP address, and then Prometheus will find that from the API, so it can keep itself kind of up to date. Okay, if I'm going to look at the targets here, what I'll see is I don't get that kind of mess of things that it found that aren't there anymore. I've got my metrics for my log components, for my web components, and the two image APIs, the two Java components. So it's found them all. It's going to use IP addresses to connect to them. Everything's looking good. It's managed to scrape everything. I've got all the metrics up. Okay, so that's cool. If I now go and have a look at the graph again, and we'll look at that IOTD image of the day thing. So there's my load total. I get the same information back. So I get the same information about whether it's been successful or whether it's been cached. And I can see the value of those things that have come through. What's different is the job and the instance. So the job is going to be the deployment name, that's the application name label that's been applied to the deployment. So this is APod API. That's part of my model. So I own what that looks like in Kubernetes, and I'll use that label for operations purposes. But that's also flowing through into here. So it's helped me tie that back to how the application has been defined. And the instance is the pod name. So that's showing me for each individual pod the information that's coming through. So it's helped me again to either aggregate at the component level or drill down to the individual pod level. Okay, so that's all looking good. So the last thing is to show what you can do with that information. At the moment, I've got all these kind of semi-meaningless numbers that are being collected. They're being scraped every 10 seconds and saved with a timestamp. Numbers can go up and down depending on how well the app's being used. What that's driving, the end goal for this, and actually perversely, you might often start with the end goal and sketch out the dashboard that you want to look at, because that's the thing that's going to be kind of cross-cutting. So different parts of your organization will have different views about what they want to see from your dashboard. So you get everyone's input, and then you work out kind of high level with not too much information that doesn't swamp everything. And then you drill down from that and say, well, we'll get this information from the client library in Prometheus, or we need to record it for this, or whatever you work out. And then you build up your metrics that you're exposing from your application containers. So that's the kind of end result. I'm going to go and deploy this now with Grafana. So although Prometheus has this UI where you can run these graphs, it's not really suitable for building a full-on UI. Once upon a time, Prometheus were going down that route, and in the end, they said, well, Grafana does that, so let's have Grafana instead. Grafana is a separate project. It's connecting to Prometheus. The configuration that I've got here is going to go and connect to my Prometheus API, and it's already deployed with a dashboard for my application. So we'll look at that dashboard now. You build that dashboard up by saying, here are the visualizations that I want, and here are the Prometheus queries that will power that. So each visualization, each graph has a Prometheus query behind it, and then Grafana is just polling Prometheus every 10 seconds or whatever you've set to be the refresh value to get the updates to drive those graphs. Okay, so let's go and browse to this now. Let's go and check everything is up and running. I'm sure it will be. Tom says he loves my book. Thank you, Tom. I'm just finishing the new one, actually, the Kubernetes one. We're in the kind of final proofreading stages. So I've read it several times over the Christmas break. I'm looking forward to not reading it again, but it should be out in February, March time, I think. Okay, so let's go to localhost. Everything's up and running. So in that monitoring namespace, again, shared component, that's where all my monitoring stuff lives. Prometheus and Grafana, so that's up and running. So I'll browse to localhost 3000, which is the default Grafana port. I'm going to log in with my credentials that are all set up in the config maps that I've just deployed, ECS and ECS, and I've got this dashboard already there, the APOD dashboard. So let's scroll out so we can see it on a single screen. And what this is telling me is the kind of high-level information. It's the same data that we've looked at, but rather than the numbers, I've got these more useful representations. So there's a different row for each component. So here's my my APOD web. It's telling me how many 200 responses there have been, how many in-flight requests I've got over time, how much memory the pods are using, and the number of active Go routines. So I'm seeing this kind of high-level, how in use is the component, and what compute resources is it using to power the requests that are coming in, the level of scale that it's dealing with. Then I've got the API, my Java API, same sort of thing, the number of GET requests that are coming through, the number of loads that have come from NASA, and the number of loads of the data that have come from the cache. This is aggregated over time, so that's why you get these, because we're looking at this for the last kind of 30 minutes, that's why you get these we're not dealing with the exact numbers here. You're more interested in the trends. And then I've got how much memory the JVM is using and the number of active threads. These are aggregates across both my pods. But if I wanted to, I could have a different line for each pod, depending on how the data that I want to see. And the last one is my Node.js thing. So this is the number of access logs that it's received, number of IP addresses it thinks it's dealing with. That's all this component does. Again, memory use and active sockets. So depending on the sort of thing that you're interested in and what you get from your platform, from your client library. So I've got Go routines here, I've got Java threads here, I've got sockets from my Node.js component that's listening for incoming data. So that one high level thing gives me an awful lot of information. If I go and just have a look at one of these things here and edit this, we'll see the Prometheus query. So this is the actual Prometheus metric. And then I'm filtering it to only be code 200, so only the 200 responses. And I'm ignoring the instance, which is that instance label. This is how I'm doing my aggregation. So every single graph has a Prometheus query behind it, and they're just firing off regularly. And all Grafana is doing is every time it runs this query, it's going to get lots of responses back for the time frame that we're looking at. And then it's going to aggregate them and show me the graph over time, which is what I've got here. It's a really simple demo dashboard. There's a lot more detail and stuff you can do. Grafana is an incredibly highly used component, and there's a Grafana there's a Grafana gallery where you can get kind of custom dashboards for standard components, like Postgres has a Prometheus exporter, which you can run inside your container to get information about your Postgres instances. And then there's a dashboard that the community have put together, which shows you interesting stuff about Postgres that you can run in its entirety, or you can take out just the graphs that you want and add them into your own component. Okay, so that's Grafana, a very, very high level of what you can do with Grafana. But the basics are, like I said, you'll often work backwards. So here's the stuff I want to see. And then here's what I get for free from my Prometheus client library. Here are the things I need to record explicitly with code. And then I'm just wiring everything up with Prometheus. So it's a kind of really nice generic way. And again, if you're running these hybrid applications across Windows and Linux, it's exactly the same. So your Windows components will have a metrics endpoint. Prometheus will just scrape from them in the same way as it does its Linux components, save them in data in the same way, and then Grafana will read it in the same way. So you get that holistic view, even if you've got older monolithic components and brand new microservice components, they all get that same way of monitoring and working with them. Okay, I think that's about it for today. So we're looking at the comments, other than the appreciative comments about the book. Thank you for that. There's no questions coming through, so Next, we're going to continue the theme of observability. Observability is not just about monitoring, it's about a kind of level of detail of understanding what's going on inside your application. So you get this kind of high level warnings when things are about to go wrong. And you can drill down into the details to find out what went wrong and fix it up quickly. What we're looking at in our dashboard here is this kind of, you have this in a big screen somewhere to impress people when they walk into your office. But behind all of these, you would also have Prometheus alerts. So, if you you can configure an alert based on the same data to things like if image loads are always going to NASA and they're not going from the cache, then ping an alert to someone, send a Slack message so someone can look into that. So it drives not just the UI, but also kind of automated responses to things that you know might happen and can be automatically fixed. Okay, yeah, so next week we are on to centralized logging. So same sort of thing, all of your components are going to be producing all these log entries that they're just container logs or pod logs. Next week we'll look at how you can centralize them all, run Elasticsearch to to store all the data, all those log entries from those different components, collect them all with this component called FluentD, and then have a visualization with Kibana. So next week, the next level of detail, which is logging, again, all about centralization, because you're going to be running in production with dozens or hundreds of containers, and you want to have a single place where you can go and look for all your logs, search and aggregate, and we will cover that next week. So thanks very much for joining. Hope you found that useful, and I will see you for the observability journey again next week.